Hello everyone, welcome to new class. Today's class is the continuation of superposition theorem. So let us do more problems related to this superposition theorem. Find the current through the capacitor using superposition theorem. So this is the given circuit and we have to find the current through this capacitor. So this is an AC circuit given. So in superposition theorem, our first step is activate one source and deactivate the other source. So here there are two voltage sources. So first of all we have to consider this voltage source, then deactivate the other. Similarly, in the next step we have to consider the other voltage source. So our step 1 is consider 50 angle 0 voltage source acts alone. Then we have to deactivate the other source. So draw the circuit again. That is, first one is 50 angle 0. Then capacitor, this is minus J5. So minus J5. Then the resistor. Then the inductor. Now we have to short circuit that 100 angle 0 voltage source. So it will be like this. So if a short circuit comes in parallel with another element, then this also will be short circuited. This element will also be short circuited. So we can draw the circuit like this. Now we can find the current through this. Let I dash current through this capacitor. So current through, that is I dash, is equal to V divided by Z, and that is equal to V is equal to 50 angle 0 divided by Z is R plus J, R plus C, that is here R part is, that is resistance part is 0. So we can write minus J5, and that is equal to 50 angle 0 divided by minus J5 is in polar form is 5 angle minus 90. So this is equal to 50 divided by 5, 10, then angle 90. So this is I dash. Now the next step is step 2. Deactivate 50 angle 0 voltage source. So while deactivating this 50 angle 0 voltage source, we will get like this. That is, deactivating means it is short circuited. Then parallel to that there is the capacitor. So it will be short circuited and current through that is I is equal to 0. So in step 2 we will get I double dash equal to 0. So in the next step, that is in step 3, we will get the value of I, that is current through the capacitor I is equal to I dash plus I double dash, and that is equal to 10 angle 90 degree, that much ampere. So in this way we are doing the superposition theorem, and this is AC circuit. Let us do another example. Find the voltage across 2 ohm resistor using superposition theorem. So this is the 2 ohm resistor and we have to find the voltage across that 2 ohm resistor. So for that we have to find the current through that 2 ohm resistor. So our first step is deactivate one voltage source or current source, then find the current. So here there are 3 sources, 2 voltage source and 1 current source. So we have to consider that 3 sources. So step 1, consider this 10 voltage source acts alone. Then redraw the circuit. So this is 10 voltage source, then 10 ohm resistor. This is 20 ohm resistor, then 2 ohm resistor. Then here this current source we have to deactivate. So it will be open circuited. So this 3 ohm resistor here we need not to draw. Then that 2 voltage source we have to short circuit. So here it will be like this. That is, this 5 ohm resistor will be there and 3 ohm resistor there will not be there. So this is the circuit after considering the 10 voltage source. Now we have to find the current through this 2 ohm resistor. So for that we can use the mesh analysis by inspection method. That is mesh analysis by inspection method. So in that we have to consider currents. Let I1 and I2 be the currents. Then write the matrix form, that is R into I is equal to V form we have to write. So here we will get self resistance 30, then mutual resistance 20 ohm, and that is minus because currents are opposite. So minus 20, here also minus 20. Then self resistance in the second loop is 2 plus 5 plus 20, that is 27 into I1 I2 equal to, here voltage is same, in direction is same as that of I1, so 10, then 0. So here we have to find only the value of I2. So I2 is equal to delta 2 divided by delta, and that is equal to delta 2 is determinant of this matrix by changing the second column elements with the voltage value elements. So we will get 200 divided by delta is determinant of this R matrix, and that is equal to 410, and that is equal to I2 is equal to, so here I2 dash, so I2 dash is equal to 0.488 ampere. Now we can find the voltage. The question is to find the voltage across this 2 ohm resistor. So V2 dash is equal to 2 into I2 dash, and that is equal to 0.98 volt. So this is the first case. Next we have to consider the second source. So let 2 ampere current source acts alone. So step 2, 2 ampere current source acts alone. Then redraw the circuit. So here 10 volt is short circuited. Then this is 10 ohm. Then 20 ohm. Here 2 ohm resistor. Then 3 ohm resistor. Current source is there, 2 ampere. Then short circuiting the 20 voltage source. So the circuit diagram will be like this. So this is the first case value. Now here also we have to find the value of voltage across this 2 ohm resistor. So here we can apply the nodal analysis by inspection method. So in nodal analysis by inspection method, we can write the matrix form, that is Y into V is equal to I form. So here let V1 and V2 be the voltages at these nodes. Then Y matrix is considering the first node. So considering the first node, we will get the self conductances connected to this first node is 1 by 10 plus 1 by 20 plus 1 by 2. It is 1 by 10 plus 1 by 2 plus 1 by 20. The mutual conductance between these two nodes is negative of reciprocal of the resistance, that is minus 1 by 2. Here also minus 1 by 2. Then self conductance connected at this node is 1 by 2 plus 1 by 3 plus 1 by 5. That is 1 by 2 plus 1 by 3 plus 1 by 5 into V1 V2, then equal to current here 0, then V2 towards this node, so 2. Then here we have to find both V1 and V2 to find the voltage across this 2 ohm resistor. So we have to find delta, that is determinant of this one. So it will be 0.419. Then delta 1 is changing the first column elements with the current elements. Then we will get it 1, and delta 2 equal to changing the second column elements with the current elements and find the determinant. So delta 2 is equal to 1.3. Then V1 will be equal to delta 1 divided by delta, and that is equal to 2.4 volt. Then V2 is equal to delta 2 divided by delta, that is equal to 3.1 volt. Now the voltage across this 2 ohm resistor is, here the current flow is in this way. So we can write V2 ohm resistor, that is V2 double dash is equal to V2 minus V1, that is equal to 3.1 minus 2.4, that is 0.7 volt. So V2 double dash is 0.7 volt. So in the third step we have to consider the 20 voltage source acts alone. So we have to short circuit this one. So short circuiting here. Then 10 ohm resistor, 20 ohm resistor, then here 2 ohm resistor. Then 2 ampere current source is open circuited. So 3 ohm resistor we need not draw. Next here 5 ohm resistor, then this voltage source. So 20 voltage. Now we can find the current. So here we have to find the voltage across this 2 ohm resistor. For that we can find the current through this 2 ohm resistor. So here this 10 ohm resistor is in parallel with this 20 ohm resistor. So first of all we can find the equivalent resistance. So this 10 ohm resistor is in parallel with this 20 ohm resistor. So 10 into 20 divided by 10 plus 20, that is 30, which is in series with this 2 ohm and 5 ohm, that is 2 plus 5, 7. So we will get 13.66 ohm. Then we can find the current through this, that is it will be like this total resistance, then the voltage source. So we can find the current through this resistor. So I total is equal to this voltage 20 divided by 13.66, that is equal to 1.46 ampere. Then we can find the voltage, that is V2 ohm triple dash is equal to 1.46 into 2, that is 2.92 voltage. So V2 triple dash is 2.92 volt. So we get 3 voltages connected to this 2 ohm resistor using this superposition theorem. Now we can find the net value of voltage, that is V2 ohm resistor is equal to, in the first case V2 dash is That is, considering this voltage source, the current direction is in this way. Then in the second case, considering the 2 ampere source, current direction is in this way. Considering the third case, current direction is in this way. So, we can write V2 dash minus V2 double dash minus V2 triple dash. So, that is equal to 0.98 minus 0.7 minus 2.92, and that is equal to minus 2.64 volt. So this is the voltage across the 2 ohm resistor by using the superposition theorem. So that is about the superposition theorem. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.